Okay, so the next test is this, test 3.2B. Exercise 3.2, these two questions, okay? Before we start, let us revise the conditions, the three conditions for a pair of linear equations that we did in exercise 3.3. So one is, if a pair of linear equation is given to us and we calculate a1 by a2 and we find this not equal to b1 by b2, then the first condition is the pair of linear equations that are given to us has a unique solution. Unique solution means only one value for x, one value for y. And so since they have a solution, we will call the system, the pair of linear equation, as consistent because they have a solution. And the lines, okay, representing the lines representing, write it down along with me, okay, their graphs, because this is going to be important to help us solve these two questions. Using their graphs intersect at only one point. Okay, so if you draw the graph of this pair of linear equation whose a1 by a2 is not equal to b1 by b2, it will be something like this. They'll cross each other at only one point. The next one, second condition, if a1 by a2 is equal to b1 by b2 is not equal to c1 by c2, then the given pair or the pair of linear equations has no solution. Okay, they have no solution. No solution means there will be no value for x or y. So no solution means, in other words, inconsistent. Inconsistent. Consistent means they have a value for x and y. They have a solution. Then no solution means inconsistent. And the lines representing their graphs means the graph of these two linear equations, their graphs will intersect. Okay, they will intersect. Not intersect, sorry, will be parallel. That means they will not touch each other. That's why they have no solution. That means if you draw the graph of first one and I draw the graph of second one, it may come out like this or like this. Never going to touch each other. That's why they have no solution. Okay, the third point here. The third point is, if a1 by a2 is equal to b1 by b2 is equal to c1 by c2, then the pair, okay, then the pair of linear equations has infinite number of solutions or infinite solutions. And so many values of x and y will come out, countless finite solutions. That means they have solution. Here also they have unique, means one solution, so consistent. Here are many solutions, so as long as there is solution, we call it as consistent. Okay, consistent. And the lines representing, and the lines representing G. Okay, this one. The line representing, let me write it here. The graphs intersect at all points. That means the two graphs will overlap each other at all points. That is, we can also call it as, if they intersect at all points, that means in other word, English word, we call it as coincident. Coincident means touching each other at all points. The meaning of this is intersect at all points, or coincident means if you draw the graph of first linear equation and you got your AB, then you plot the graph of the second equation, it will be the same line. So those two lines of the two equations are overlapping at all points. So coincident means it's the same line. Okay. Let me check the video once whether it's proper or not. Okay, so I think it will be fine. So here, once we're finished, oh sorry, that's not representing. And the lines representing there, DHEIR. Okay, the lines representing there, graphs intersect at all points, and all points means the graphs are coincident. It's the same line, that means. So with these three conditions in mind, we'll do question B1 and B2. Okay, so B2 and B3, sorry, B2. Let us do that first. Page 51. Let me read the question once. On comparing the ratios A1 by A2, B1 by B2, and C1 by C2, find out whether the lines representing the following pairs of linear equations, they intersect at one point, they are parallel or coincident. Okay, so yes, so we'll start with this one. Question number inconsistent, the lines will be pair. Okay, so here, number one, let's write a given equation. Now, while doing this pair of linear equations, to determine these three conditions, you intersect at one point, parallel or coincident, we have to be very clear about this. X term in first place, usually. Y term, for Y is the Y term in second place, and the term having no X and Y is called the C1. So C1 is on left side is equal to 0. That's fine. So here let's put this one as equation 1. Then 7x plus 6y, x term C first place matching, and C2 minus 9. C2 means the C in the second equation on the left side. Both are on the left side, that is okay. So this C1 and C2 should be both on left side, same, or both on right side. But C1 on left side and C2 on right side, like that we should not do, then we will get these conditions wrong. Okay, so let me just put here a line to separate. So from equations 1 and 2, as the question is saying, find out A1 by A2, B1 by B2, C1 by C2. So A1 by A2 is A1 and A2 are the coefficients of X in equation 1, 2. So coefficient of X means cover the X and whatever is in front of X. In the first equation, no sign, so plus 5, and here plus 7. So plus 5 is A1, plus 7 is A2. Then you check whether you can cancel them, because we need to express it in the lowest term or standard form. We cannot, so it's already in the standard form, so we can leave it like that. Then go to B1 by B2. Means B1 and B2 are the coefficients of Y. So just as you did for X, cover the Y. Whatever is in front of Y, read it out. Yes, minus 4 is B1 numerator, and B2 is here plus 6. we see that we can cancel. So you can cancel. 2 2s are 4, 2 3s are 6. So cancel and bring it to a point where you can't cancel anymore. We can't cancel 2 and 3 anymore. So you write your minus 2 by 3. Then we notice that A1 by A2 is 5 by 7. B1 by B2 is minus 2 by 3. And clearly they are not equal. So if A1 by A2 is not equal to B1 by B2, it's condition number 1. So you could, in such a case, you don't need to bother to find C1 and C2 because we don't need it because we already got the first condition. So you write here, therefore we see A1 by A2 clearly not equal to B1 by B2 when we found them 5 by 7 and B1 by B2 minus 2 by 3 are definitely not equal. So since they are not equal, the question is saying determine whether they are intersect at one point, parallel or coincident. So since A1 by A2 not equal, this is the one, they intersect at only one point. So this is what we'll write. Therefore, the lines representing lines, I'm just using the same language as the question, that's easier, representing the pair of linear equation. Pair means these two pair of linear equations intersect at a point. So that is our first answer. I hope you're getting right. Then let's go to B2. B2 subheading 2. So B2 subheading 2. Obviously these equations will change. I read out 9x, the first equation given is 9x plus 3y. So x term first place, y term normally second place, and C1 means the term with no x and y, 12, C1, left side, equals 0, that's fine, just give us 1. The next one, 18x plus, sorry, excuse me, so 18x plus 6y plus C2, 24 means the term having no x and y is called C2 or C1, both on left side, so that's correct, as I've said in the first case also. Or you can put both of them on the right side, that's also correct. But one C1 on left side, C2 on right side, or C1 on left side, C2 on right side, that will be wrong. We'll get this condition wrong. So let's start here. A1 by A2, coefficients of x very clearly plus 9 and 18. Clearly we can cancel, so 9 1s are 9, 9 2s are 18. Can't cancel anymore, is expression is 1 by 2, that's the standard form. Comma B1 by B2, coefficients of y here 3 by 6, can cancel, 3 1s are 3, 3 2s are 6, 1 by 2. We see that A1 by A2 and B1 by B2 are both equal to half, so they're equal. In case these two are equal, then you go and find out only after that C1 by C2. And C1 by C2 will be this, C1 is 12 by C2 is 24. Cancel as much as we can, so 12 1s are 12, 12 2s are 24, so 1 by 2. Therefore we see that A1 by A2 is half, B1 by B2 is also half, C1 by C2 is also half. All three are equal, so I'll just put equal signs between them. So if they are equal, this is the condition C, number 3. Then the lines will be, and the lines representing the graphs intersect at all points, okay, and the pair of linear equations has infinite solutions. That means and the lines representing their graphs will be intersecting at all points or coincident. So let us see what does the question say. Whether they are intersect at one point, they are parallel. Parallel is second condition. See here. Parallel is this one, not this one. Unique is this one, also not this one. So coincident. A1 by A2, B1 by B2 equal to C1 by C2, then they are coincident, the third one. So I'll write here, therefore the lines representing okay, the pair means the given pair of linear equations, okay, are coincident. The question is saying find whether they intersect at one point, the lines are parallel or coincident, and the choice we know is the third one, A1 by A2 equal to B1 by B2 equal to C1 by C2, exactly like this. So there will be this one, coincident. Hope you're getting right. One more, the third one. Okay, so let's go and do the third one. The third one is B to subheading 3. Here also x terms 6x plus 3y in the second place plus 10c1 on the left side equal to 0, equation number 1. That's fine. Next is 2x minus y plus 9c2 also on left side, so it's already arranged, so 2. So I forgot to put here, I think, but that's fine, not so strict. But here if you can put from equations 1 and 2. Question has asked us to find, so A1 by A2 is equal to this coefficient, so 6 by 2. So 2 1s are 2, 2 3s are 6, so 3 by 1 means 3, comma, B1 by B2. Here 3, and down here is in front, non-number means 1 is there, and the sign is minus. Can't cancel, so this minus will go always to the numerator, minus 3. Immediately we find A1 by A2 is plus 3 and B1 by B2 is minus 3, so they are not equal, so it is the first one. And as I said, since minus, oh sorry, this is minus, sorry, I made a mistake here, go ahead and please correct it, minus, so minus 3, sorry. So here, please correct slightly, minus and minus cancels, 3, sorry, they are equal, see, minus and minus cancel, minus 3 minus 1 plus 3, A1 by A2 equal to B1 by B2, put 3, then only then you go and find out the C1 and C2. So C1 and C2 is here, C1 is 10 by 9, C2, we can't cancel, so you just write that one like this. So we see clearly that here A1 by A2 is equal to B1 by B2, because both are 3 plus 3. But these two are not equal to 10 by 9. 3 is not equal to 10 by 9 means not equal to C1 by C2. So which is this condition? This one, see. A1 by A2 not equal to B1 by B2, not equal to C1 by C2. Then the question is saying intersect at one point, parallel or coincident. So definitely parallel. You can see the word parallel here. So therefore the lines representing the pair of linear equations are parallel. Okay, so we have done question B2. We'll do the B3 in the next class. Okay.